Alright, well, if you're anything like us, your pump just froze and you just blew part of your housing apart. In our case, we blew the motor adapter out on this Goulds J10s, 1 horsepower, and it just sheared one of these dog ears off, just like that. I'll show you here in a minute. So, we were able to get a well expert out here, and he was able to get us a salvaged part and put that in there at no cost to us because we're a non-profit and we're good at squeezing free stuff out of people. But anyway, I've got that old motor adapter lying around, and I'm gonna see if I can JB weld it back together and formulate a hack job emergency last ditch repair so that I have something, lying in wait nearby in case this happens again, because it may just. I'm getting ready to build a little pump hut. It's not quite a pump house, but it's a little pump hut just to cover this thing, house a little light, and keep it from freezing again. But I figured I might as well take you along for the ride and see how well we do. I'm not going to test it on this pump because it's not my pump, and I don't want to break it. But if you find yourself in this situation, this may be useful to you. I can't promise you it's going to work because I'm not going to test and verify. But one of these motor adapters is like $160 plus tax. And then you also have to buy this mechanical seal in here for the motor. And that'll probably run you another 20 bucks. So you're looking at probably about $200 doing it yourself. Not even if you get a plumber out here to do it. So, tube of JB Weld's $5. Can't hurt to give this a try. So, without further ado, let's get to it, and we'll see. We'll see if this looks like it's gonna do anything or not. All right. While you're out here, the first thing you need to do before you start pulling this thing apart is you need to check your ear spacing on one of these sides. If your crack is like mine and where it's sheared off one of these ears, first thing you need to do is you need to find your ear spacing, what it is on your pump. On mine, it's just a hair over an eighth. It's something close to 9/64ths, maybe even 5/32, closer to 9/64ths. And the reason why you want to know this is because when you JB weld this sucker back together, you're not going to be able to put the torsion on here like you can with this cast iron. Because you do that, it's just going to crack your epoxy, and then you'll be back to square one. Because this forms basically a spring seal this whole way around. These bolts clamp down, and it forces this cone into this housing, and it seals it pressure tight. So when you put that JB weld in there, that bond with that epoxy is not going to be as strong as the bond within the cast iron, at least as far as I'm aware. JB weld's kind of a miracle substance, but I don't know if it's that miraculous. So as a stopgap, just sort of as a band-aid, what I'm going to do is I'm going to place a stack of washers or a couple of spacers in here, something on this bolt on mine where it's broken, so that when I torque that down, it bottoms out just slightly above this gap. So I'm probably going to go with 5/32 and just expect the metal I stick in there to squish down a hair. So that way, when you torque that down, you can't torque it past this gap, because this gap right here that you have just measured with your tape measure is where yours needs to be to seal. So after we get all this fixed and get it all filed back down and get it nice and level and back to shape, you need to put a spacer in here so that when you torque this down, you don't go too far and break it and put yourself back at square one. So you need to get your gap. Mine is about 9/64, so I'm going to put 5/32 stack of washers in here just to keep this at this gap and not go any smaller, because any smaller and it's going to break. And I'm hoping that 3 of these bolts plus partial torque on a 4th should be enough to seal this well enough. And if it doesn't, you can probably cheat and put just a smidge of blue RTV on the outside of this, just to form a slightly better physical seal. But That's my supposition at the moment. That may change towards the end of this video. Alright, so let's get to fixing this crack. Ignore the fact that I'm boiling thermostats right there, but we're just going to take a brass brush and we're just going to clean all of this rust out of here, because cast iron rusts like a son of a bitch almost immediately. So I'm just going to de-rust this as well as I can with a brass brush. Then I'm going to come in here with a brand new iron brush, clean all that out of there, and if I can find a, I think I've got some iron wire wheels in there, I'll go after it with the drill, get this as absolutely clean as possible. Then I'm going to come over here and hit it with some carb cleaner, and then just to be extra certain, some brake cleaner. I'm probably just going to go whole hog with the brake cleaner to get all of the rust off of this. I'm going to do the same thing with this down here. I'm going to try and keep the brake cleaner off of this plastic fitting right here because it will melt it, which is probably why I was planning on using the carb cleaner. I also want to keep the brake cleaner off of this down in there because it will melt that rubber. I think I am going to go with carb cleaner, but anyway. The miracle substance we are using is JB Water Weld. You can probably, it's probably better to use metal weld, but water weld is very much water resistant, and I already have that because I was using that for something else, so I'm gonna go with that, and we're gonna see if it works. So really nothing crazy to it as far as gluing it. Just get all of your rust out of here, clean all your pores as much as you can, and then degrease it as best as possible so that you get a perfect fit. Let the degreaser evaporate, and then just mix up some JB Weld, squish it, stick it down in there, glue it back in, get it as tight as you possibly can, hold it there, let it set, and then after that we're going to sand it so that it is level the whole way around, because this is a sealing surface, so you want this to be flat. So I'm gonna get to that. Look at that, brand new, nice and clean. Just hit her with a little bit with the brass brush just to knock the obvious rust off. Then I went after it with the steel brush for a bit, and then I got lazy and I just went to this steel one on the drill, and then I finished it up with this, and there's still a few little rust spots like down in there, you know, just little bits where you can still see some orange, and I'm gonna go after them a little bit more. And there's a very specific reason why I'm not using sandpaper, because steel on steel is not going to remove much metal, but sand on steel, because sand is significantly harder than steel, is going to just gouge all of this out. And it's going to take all of this grain out, and I want as much of this, you know, significantly rough, you know, three-dimensional geometry going on here as possible to get this JB Weld to make the best stick. It's also going to mean that this is going to mess up the geometry, because if I take some of this material out of both of these and then I stick it back together, it's going to fit a lot tighter, and I'm going to be able to line it up right and let it set, and I'm not going to have to do as much sand work to get this seal right. But I want maximum stick, because that's what I really care about here. I can make this seal. I can't make this stick unless that does it. So I'm leaving this grain exactly as it is, and I'm just taking all the rust off so that that rust doesn't impede what the JB Weld is doing. So I'm going to move on to finishing up that, then doing that, and then hitting both of those with carb cleaner so I don't accidentally break one of these. I'll hit that one with brake clean because I got nothing on I need to worry about. Other than the paint maybe, because that may melt the paint. We'll see. I think this is enamel, but yeah, just prep work. Alright, so I've degreased both of these with carb cleaner, let them dry off for a bit, wiped off as much of the excess as I could with a nice clean rag, and I'm going to take this little piece of water weld, which is just sort of eyeballed into roughly what I think I'm going to need. I'm going to need a lot less than this, but I just want enough that I can actually, you know, get it where I want it. And there's some crumblies in here because I've used this before, so the end of it's cured, which I probably should have cut off, but I'm not going to. Also, I'm kneading this with rubber gloves just because I'm trying to keep, you know, as much oil as I possibly can out of the putty. Not that it's really going to help much, but, you know, worth a shot. I had a rubber glove lying around. Might as well. Plus, it keeps my hands clean. So, I'm going to get to kneading this for a good bit, and then I'm just going to slather it on there, push that in, clean up, you know, the excess, push some stuff in holes, jiggle it around, force it in as much as I can, and I'll show you what I've done. Alright, so here's what I've done. Just slathered it on there as I could, and it's only going to be a very thin amount that's actually in there. But regardless, slathered it on there, squeezed it in there as best as I could, and then put a bunch of clamps on it just to hold it in place. And I want this as flush as possible. Ain't gonna be perfectly flush, but I want it as flush as I can possibly get it. Ideally, you want this to match it. And so that's where I was saying is if you could hog some metal out of here, get a very loose fit, and then just get this lined up perfectly and let the JB Weld fill the gap. I'm trying not to do that because I got that really rough grainage going on in there. So I'm just going to try and sand it to fit. And just pray that the JB Weld holds together enough that I can make this thing work as a temporary stopgap in the emergency event that we need another one of these. If you want to be absolutely certain this thing is going to work, I would recommend you get in there, hog that out, take about maybe a 1/16 of an inch of metal out between both of them, 30 seconds from one, 30 seconds from another, so that you have a very loose fit, so that when you fit that in there, you have a bit of a gap, and then just fill that as flush as you can with JB Weld, kind of like you're doing Bondo work. And then when you get this to set, like I'm doing right now, set it on a flat surface and press it, put a center block on it or something, and get this surface as flat as possible and as this surface as concentric as possible to the original part. Because that's the key, because once again, this seals. This is a sealing surface. So if I put this back on there, I'm going to have to put some RTV or something on there, unless I can do some sort of super special magic. But considering how this is sitting proud against the rest of the housing, I'm not going to be able to sand that much material off. So it will need some kind of external sealant to fill up that gap, a gasket of some shape and form. So anyway, I'm just going to let that cure overnight, and we'll monkey around with this in the morning. Okay, so here's a little bonus for you. You see this pressure gauge? Well, it ain't got no pressure on it, and it's reading 22 psi. So you can actually get in here and fix these, because this is bent. I'm assuming it froze and then it bent, so now it's reading wrong. And I have fixed these on tire gauges before, so I'm going to show you what you can do to get in here and make an attempt to fix on this, save you $5. So you got to take the top glass off. On this one, it's a press fit on there, and I had to basically take a flat blade, and I just turned it over, and there was a little lip on the edge, and I just ran it around like that, and just basically held the screwdriver in one hand, and then moved the gauge up in the other, and just whapped it on the lip, and just went around the edge and did that twice, and then it popped off. And that one actually has a glass cover on it, so be careful with yours that you don't drop it. Then there's two Phillips heads on the back, holding the whole gauge assembly in place. Just take them out. I already loosened mine up and then accidentally torqued them back down. So I'll probably need two hands to take that off, so stand by. Once you got those two screws off, and on this one it's got a fully enclosed thing down here on the bottom, so you have to pivot it up like that, and then sort of wiggle it out like that, and you've got the gauge. And now all you need to do is clean out all these dead spiders, and you need to torque this copper element right here. And I don't know if it's any different for something that's frozen, but on one that's dropped, all you really got to do is you just got to bend it ever so slightly, like that. Just keep going like that, get in it with needle nose pliers and bend it right down there where it's soldered. Don't try and bend this entire assembly, just bend the part where it's soldered. And after you do this, you are going to have to calibrate this. That. See, I probably just went way too far right there. Yeah, I bent the shit out of that. So it's don't do it with one hand like I'm doing it. Just get it to the point where it's almost bottomed out, and then give it a little bit more, and then recalibrate it to something. Get an air compressor, get a pressure gauge that you know works, like a tire pressure gauge, and hook it up to the same thing and read the pressure, and just make sure that it's reading correctly. But that's all you got to do to fix that, is just bend that little copper tube down there. So I'm going to get to tweaking that, and then I'm not going to calibrate it because I'm just going to throw it in a drawer somewhere and have it as a spare. But that's how you can fix one of those in case you're in a pinch. Alright, so I got her back together, and if you believe that gauge, we're at 50 psi, and if I can do this one-handed, I'll fuck it up immediately. She's reading pretty dang close. So I'll call that good. And we'll throw this in a drawer somewhere. Yes, she's pretty much on the money. Okay, so it's been about 5 hours or so, and as you can see, the epoxy is mostly cured. So I'm just going to get in here with the razor blade and the wire brush and just knock off a lot of this excess epoxy here on the ceiling surfaces and down here the impeller housing where it may cause some harm. Just while it's still got some give to it, so I don't have to sand all of it off at later tomorrow. But not going to be doing the finishing work just yet. Well, as you can hear from the artillery outside, it's New Year's and I'm a little bit sauced up, so I'm feeling cheeky, so I just went ahead and did all the finish work even though this stuff isn't cured yet. I just went after it with a metal file, wire brush, and some, I think 80 grit sandpaper, might be 120, I don't know, I can't read. And yeah, I got her a lot better than I thought I was going to get. She's a little proud on the seam right there, I need to hit that again. And that's nice and flat, although I did kind of overdo it right here, so now I got a low spot. So we'll ignore that. But top is nice and smooth. So we're just gonna go with that. Key is you want to get a taper on this because this thing is sticking up like that. So you want to taper it in so that it lines up and is concentric. And if you want to be really cheeky, you can go ahead and spray this with some enamel paint or something like that. We're trying to do this for $5, so we're not doing that. And yeah, and the other thing is you want to get this as level as you can get it so that when it smooshes down in there and this fits to the inside of the housing like that, this will form a watertight, pressure-tight seal. So I just need to hit that lip right there just a wee bit more, get that back down, and I think that's good to go. Then I just need to figure out my 5/32 spacer for up here. And I've got a big old pile of washers around here somewhere, one of these drawers. I don't know which. But there's a bunch of washers, and there's washers there, and there's washers there, and over there. So I'm just going to hunt around and look and try and find a pair of them, or at least one big fat honking one that'll come up to 5/32. Alright, so that's beautifully smooth now. And I found these two washers that together total 5/32, and I don't know if that smaller one is the correct diameter, but we'll just leave it here and future me will figure it out if it ever becomes a problem. And yeah, that's it. Since mine is going into storage, I'm just gonna get a little bit of silicone lube, which is probably very much the wrong thing. I should probably be using gun oil, which I have, but I'm too lazy to go get. I'm just going to grease this down just so that these bare metal surfaces don't rust like an absolute son of a bitch, because I don't have any primer or anything laying around that I can use. And if I just spray it with spray paint, it's just going to rust right through that. So I'm just going to slather it down with grease and just let it ride. But yeah, hopefully if you're in a pinch, hopefully this works for you. I mean, no promises. This is really like a coin toss at best. Whether or not this is going to work for you, especially whether or not your crack is something that can actually be fixed. Luckily, mine was right on the corner, so it just sort of popped off, so I was able to just sort of suck it back down in there, stick it back into place, and epoxy it. But if you've got something where it just like split it, like that, like a banana peel, you're kind of fucked. If your ceiling surfaces are still intact and you've just sort of got a hole, you might be able to just get in there with an angle grinder and just grind it out and just jam some epoxy in here. This is all cast iron, so it's an absolute pain in the ass to weld, and I can't weld to begin with, and I don't have a welder. But I have read that you can braze cast iron pretty easily. Well, not easily, but easier than you can weld it, and you don't have to have a welder to braze. And I hear that works better for stuff like this, especially when it's a non-structural thing. So if you've got the technology, you can try that. And I went at this with a hand file, so it's not precise. If you had a machine shop, you could slap this bad boy on there and spin it and just turn this down level. But if you have a machine shop, you know someone who can weld, and then yeah, you know your time is money. So you're probably not going to be fooling around with something like this to save $200. But anyway, yeah. Hopefully this helps. Doesn't really help me, but hopefully it helped you in some way, shape, or form. Maybe. Till next time, Tom out.